Dear students, today class we will discuss regarding various antenna parameters. What are the various antenna parameters? In this class, we are going to study one by one various antenna parameters. What are these antenna parameters? For example, if you want to test any antenna. So, for example, if you want to buy anything, if you want to buy a TV or if you want to buy a laptop, there are certain parameters usually refer. For example, if you want to buy a laptop, then you'll go for what is the internal memory, and similarly, what is the external hard disk, what is the processor. These are all the things we consider. Similarly, for an antenna, if you want to test an antenna, or if you want to design an antenna, there are certain parameters that should be considered. There are so many 14 to 15 parameters are there, various parameters are there we are going to consider. Now we'll study one by one. In this, the first one we'll study the radiation pattern. What is meant by this radiation pattern? What is the radiation pattern of an antenna? The definition of the radiation pattern of an antenna is defined as mathematical function or graphical representation of the radiation properties of an antenna as a function of space coordinates. I once again repeat, it is a mathematical or graphical representation of the radiation properties of an antenna as a function of space coordinates. Okay. Coming to the radiation pattern is broadly classified into two types. One is field pattern, and the other one is power pattern. What is meant by this field pattern and what is meant by this power pattern? Field pattern means if field pattern, or it is also called as linear scale, if the plot of the magnitude, if the plot of the magnitude of electrical field or magnetical field as a function of angular space, it is called as field pattern. Or if the radiation of an antenna, if the radiation of an antenna is expressed in field strength, if the radiation of an antenna is expressed in field strength. Field strength means what is the field strength? Either maybe electrical field strength or magnetical field strength. Then such type of radiation pattern we call it as field pattern. Or there is the other type. What is the other type? The other type is power pattern. What is meant by this? Power pattern. The power pattern typically represents a plot of square of the magnitude of electric or magnetic field as a function of angular space. Or other definition of the power pattern is if the radiation pattern is expressed in power per unit solid angle. Expressed in if the radiation of the antenna is expressed in power per unit solid angle, such type of patterns are called as power pattern. It is clear if the radiation is expressed in as electrical field strength or magnetical field strength, we call it as field pattern. If the radiation is expressed in power per unit solid angle, then such type of radiations are called as power patterns. Okay, so these are the two broad classifications of radiation pattern. Radiation pattern is broadly classified into field pattern and power pattern. Now, so this radiation pattern is three-dimensional. This radiation pattern is three-dimensional. Okay, so I cannot draw this three-dimensional on a plane. So what I'm going to do is I am going to divide this three-dimensional into two-dimensionals such that I can analyze all the characteristics. I cannot draw the three-dimensional plot on my paper. Okay, so what I'm going to do, I'm simply making the three-dimensional into two-dimensional plots. Two-dimensional plots. Coming to the field pattern, that field pattern, the three-dimensional field pattern can be divided into two-dimensional plots that are called as vertical plane and horizontal plane. Vertical plane is also called as E plane. Horizontal plane is also called as H plane. And once again repeating, any field pattern which is three-dimensional can be converted into two-dimensional plots that is called as E plane and H plane. E plane is nothing but vertical plane. H plane is nothing but horizontal plane. What is meant by this E plane and what is meant by this H plane, or what is meant by this vertical plane, or what is meant by this horizontal plane. For example, so see here, if you take an apple, if you cut like this, if you cut like this, or if you cut like this, there are, if you cut like this, the image will be one thing like that. If you cut like this, the image will be like this. So, if field patterns again classified into two things, field patterns are again classified into two things. One is vertical E plane or E plane. So, what is meant by this E plane? E plane means, go to the whiteboard. Okay, so what is this vertical pattern? For example, vertical pattern. Vertical pattern means, so here you know that there are the three things. Okay, in a spherical coordinate system, three things are to be considered: r, theta, phi. What is the range of theta? The range of theta is from 0 to 180 degrees. What is the range of phi? The range of phi is from 0 to 360 degrees. 0 to 360 degrees. Okay. So, for example, the vertical. Now, let us discuss first about vertical plane. Vertical plane or vertical plane or E plane. What is meant by this? Vertical plane or E plane. If the pattern which is obtained by plotting normalized field strength, the pattern which is obtained by plotting normalized field strength versus theta, keeping keeping uh, keeping phi as constant, keeping phi as constant, we call it as we call it as vertical pattern. Means, so I am I'm going to discuss regarding vertical pattern. So, first regarding vertical plane or E plane. The other thing it is E plane. What is meant by this vertical plane or E plane? So the pattern which is obtained by plotting normalized fixture, normalized normalized field strength. We will discuss what is meant by normalized field strength in next step. Versus theta keeping phi as constant, keeping phi as constant. Okay, so this is called as vertical plane or E plane. Vertical plane or E plane. Okay, this is called as vertical plane or E plane. Similarly, what is meant by this horizontal plane, or what is meant by this other one is horizontal plane or H plane. Horizontal plane or it is simply reverse to this. Okay. So the pattern which is obtained by plotting normalized field strength as versus keeping theta as constant. Okay. So the formula for it is the expression, the definition for it is normalized field strength, normalized field strength versus phi. Okay. Here keeping theta as constant. Keeping theta as constant is called as horizontal plane or H plane. Okay, it is clear. So, what is meant by a vertical plane and what is meant by an horizontal plane? Okay, so horizontal plane means it is pattern which is obtained, we are converting a three-dimensional plot into two-dimensional plots. One is either in E plane or H plane, or it is vertical plane or horizontal plane. What is meant by this vertical plane? So the pattern which is obtained by plotting normalized field strength versus theta, keeping phi as constant, is known as vertical plane. What is meant by horizontal plane or H plane? The pattern which is obtained by keeping normalized field strength by plotting normalized field strength versus phi, keeping theta as constant. Keeping theta as constant. Okay, so for example, let us take one expression. Let us take one expression. Uh, Let us see. Now, let us take one expression. Okay, so in this expression, for example, let us take E is equal to sine theta. E is equal to sine theta. E is equal to sine theta. Okay. So vertical plane. Vertical plane means it is normalized electrical field component versus theta, keeping phi as constant. Keeping phi as constant. Phi as constant. Okay. So here the range of theta, for example, let us take here theta, you can vary from 0 to 180 degrees. Okay. So if you vary theta from 0 to 180 degrees, okay, so the plot you may get like this. Plot will get like this. So this is called as vertical plane. It's called as vertical plane or E plane. It is called as E plane. So the value of sine 0 is 0, sine 90 is 180. Again, sine that one 180 is 0. Like this is vertical plane. Okay. So similarly, coming to the horizontal plane. Horizontal plane. Okay. So here the expression is E is equal to sine theta. Okay. Here no phi component is there. No phi component is there. Here I am keeping theta as 90 degrees constant. Here I am keeping theta as 90 degrees constant. What is the expression for horizontal plane? Normalized field strength versus phi, keeping theta as constant. Keeping theta as constant. Okay. So since what is the value of sine 90? It is 1. So the value is entirely, it will looks like. Okay. So this is the pattern we have obtained by using vertical pattern, and this is the pattern we have obtained using horizontal plane. Horizontal plane. This is nothing but if you look at this, if you look at this, if you cut an apple, if you cut an apple vertically, if you cut an apple vertically, the structure will looks like this. The structure will looks like this. Similarly, if you cut an apple horizontally, and if you open like this, this horizontal plane comes into picture. This is horizontal plane comes into picture. Okay, so this is how the three-dimensional plot, the three-dimensional plot, either field pattern can be uh, shown in two-dimensional plots. Why you are showing the three-dimensional plot in two-dimensional plots? Because the three-dimensional plot we can plot cannot plot on the paper. So instead of that three-dimensional plot, we are plotting that plot into two-dimensional plots, that is E plane and H plane. E plane and H plane. Okay, so this is the okay, next. What is meant by this? Okay, up to now we have studied regarding field pattern. Up to now we have studied regarding field pattern. Now we'll study regarding power pattern. Now we'll study regarding power pattern. So as I have already told, the field pattern is divided into two two things. Okay, the field pattern is divided into two things. One radiation pattern is divided into two things. So the radiation pattern is divided into two things. One is field pattern and the other one is power pattern. Okay, now we will discuss regarding power pattern. I have already told that the power pattern, if the radiation pattern, the radiation of an antenna is expressed in power per unit solid angle. Such type of patterns are called as power patterns. Okay, so this power pattern, what is the relationship between power pattern and field pattern? What is the relationship between power pattern and field pattern? So the power pattern is proportional to the square of field strength pattern. The power pattern is proportional to the square of field pattern strength, square of field strength pattern. The power pattern, what is the relationship between power pattern and field pattern? Power pattern is proportional to the square of field strength pattern. For example, if the field strength pattern is, if the field strength pattern means that is E of theta comma pi is equal to sine theta. This is field strength pattern. Then power pattern is represented as simply nothing but field pattern whole square. So what is its value? Power pattern. Its value is sine square theta. Very, very important. Okay, so this is the relation. If the field pattern is sine theta, then the power pattern, the representation is sine square